Welcome to the video lecture series on digital electronics for second year BSc third semester electronics paper 3. In these videos, we learn about different type of number systems that are used in digital electronics and various binary codes. We will discuss about various types of logic gates, Boolean algebra, representation and minimization of Boolean functions by using K-map minimization technique. We learn how to design combinational logic circuits as well as sequential logic circuits. These are the two types of digital circuits. At the end, we will discuss about some of the basics of memory. So the different type of operations and different type of memories we will discuss. At the end, we will discuss about two important programmable logic devices like PLA and PAL. The first topic is about number systems. So, a number system is a systematic way to represent and manipulate numbers. That is, it is used to represent numbers as well as to do some manipulations on that numbers as well. For any number system, in general, we define one parameter that is called base, or it is also called as radix, which is represented with small r. So, for any number system, the base or radix value defines the number of distinct digits. It defines the number of distinct digits. Distinct digits that are used in a number system. So that's the meaning of the base. So for every number system, we define this value. So this value tells you how many number of distinct digits that are used in a particular number system. So in this topic, we will discuss about four types of number systems. Four types of number systems. Namely, decimal number system, second one is about binary number system, third one is octal number systems, and at the last, the fourth one is hexadecimal number system. For all these number system, the base value is different. For example, for binary number system, for decimal number system, the base value is 10. So deci stands for 10, so its base value equal to 10. That means it uses 10 different symbols to represent a number. For binary number system, the base value is 2, bi stands for 2. It uses two different symbols to represent a number. For octal number system, the base value is 8. 8 octal stands for 8. So it uses 8 different symbols to represent a number. For hexadecimal number system, its base value is 16. That means it uses 16 different digits or 16 different symbols to represent any number. So let us discuss one by one in detail. First, we will discuss about decimal number system. We are very familiar with these number systems because in our day-to-day activities, we use this number system only. So the radix of the decimal number system is 10. So that means it uses 10 different digits to represent any number in this number system. So those 10 digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the 10 different symbols or 10 different digits it uses. For every number system, each digit has a positional value. So that positional value depends on its base value. So in decimal number systems, each digit has a positional value which is in the power of 10. For example, let us consider a decimal number 25. So here 2 and 5, both the digits having a specific weight. So the positional weight of the 5 is 10 power 0. The positional weight of the 2 is 10 power 1. So the positional weight of 10, sorry, the positional weight of 5 is also called as a units place, and 2 is also called as a tens place. So likewise, each digit has a positional value. For decimal fractions, let us consider a number 16.21. So for a fractional value, the positional value varies in the power of 10 in negative order. So that is, the positional value of 2 is 10 power minus 1. The positional value of minus 1 is 10 power minus 2. So likewise, the positional value is different for integer part as well as fractional part. It is in the power of 10. And we can define two examples. So the first one, 125.45 base 10. It's a decimal number. Clearly, it is a decimal number because for the formation of this number, we use 1, 2, 3, 4, and 5. So all these digits belongs to 0 to 9 digits. And in the second example, 12A2 base 10, clearly this is not a decimal number because in the formation of this number, we used one alphabet. So that alphabet is not a part of the decimal number system. Now coming to the binary number system, whose radix is 2. So that means it uses only two different digits to represent any number. And those two different digits are 0 and 1. And every digit in this number system has a positional value which is in the power of 2, and these two digits are also called as bits. For example, I can define a binary number like 101.01. So in this case, each digit has a weight which is in the power of 2. That is, the weight of the 1, the first number, is 2 power 0, the second digit is 2 power 1, and the third digit is 2 square. Similarly, for the fractional value, the weight is 2 power minus 1 and 2 power minus 2. And we define two more examples. In the first example, it is a binary number because the entire number is composed of zeros and ones only. In the second example, this is not a binary number because in the formation of the number, along with the 0 and 1, we used one more digit, that is 2, which is not a part of the binary number system. For octal number system, the base is 8. So that means it uses 8 different digits to represent any number. So those 8 digits are 0, 1, 2, 3, 4, 5, 6, and 7. So whenever you define any number in octal number system, you are allowed to use only 0 to 7 digits only. And every digit in this number system has a positional value which is in the power of 8. For example, let us take a octal number 72.01. So in this case, each digit has a positional value, and this positional value for the 2 is 8 power 0, and for the 7 it is 8 power 1. For a fractional value, it is starts with 8 power minus 1 and 8 power minus 2. So in the examples, you can consider one more example, that is the octal number 123.45. Clearly it is an octal number because for the formation of this octal number, we used 1, 2, 3, 4 and 5. So these digits belongs to the octal digits. And in the second example, clearly it is not an octal number because in the formation of this number 1 to A2, we used one alphabet A, which is not a digit of octal number. For hexadecimal number system, hexa stands for 16. So the base of the hexadecimal number system is 16. So that means it uses 16 different digits or 16 different symbols to represent any number. So those 16 different symbols are, it uses 0 to 9 digits and A, B, C, D, E, and F alphabets, right? Instead of 10, it uses A. Instead of 11, it uses B. Instead of 12, it uses C. Up to instead of 15, it uses F. The reason, because the use of A, B, C, D alphabets are after 9, in general, after 9, we will define 10. But 10 is not a distinct digit. 10 is a combination of 0 and 1. So it is not a distinct digit. So to make it a distinct digit or a different symbol, instead of 10, it uses A. Instead of 11, it uses B. So that's the reason why we are included A to F alphabets in this number system. Every digit in this number system has a positional value which is in the power of 16. For example, let us consider an hexadecimal number, that is 2a.2c. So for this number, the positional value of the A is 16 power 0. The positional value of 2 is 16 power 1. So similarly, the positional value of the integer part varies from 16 power minus 1 and 16 power minus 2. And two more examples are given at the end. In the example 2, clearly it is an hexadecimal number because in the formation of this number, we used only 1, 2, 3, 4, 5. Clearly, these digits belongs to hexadecimal number system. And in the third example, we defined one number 1 to G2 base 16. Clearly, it is not an hexadecimal number because we used one undefined symbol, that is G. So the letter G is not a part of the hexadecimal number system. In hexadecimal number system, only the allowed alphabets are A to F. We can summarize all these four number systems based on their base and the number of digits used. For decimal number system, the base value or the radix value is 10. That means it uses 10 different digits. Those 10 different digits are 0 to 9. For binary number system, the base value is 2. That means it uses only 2 different digits, that is 0 and 1. These two digits are also called as bits. For octal number system, octal stands for 8. So its base value is 8. It uses only 0 to 7 digits to form any number. For hexadecimal number system, hexa stands for 16. It uses 16 different symbols or 16 different digits to represent any number. And the allowed digits are 0 to 9 numbers and A to F characters are allowed to use in this number system. By knowing these four number system, we can quickly find out the base as well as the base of the following number systems. You can see in the example 1, I defined one decimal number. Clearly, is it a decimal number? Yes, it is a decimal number because it is in the formation of the number we used only 0 and 1. Clearly 0 and 1 belong to the decimal number system. Apart from the decimal numbers, and this number has the possibility to be a binary number and a octal number and a hexadecimal number as well, because in the rest of the three number systems, binary, octal and hexa, the 0 1 digits are allowed. In the second example, we defined a number to be an octal number, as clearly it is an octal number because in the formation of the number we used 0 1 and 2. 0 1 and 2, these three digits belongs to the octal number system. Along with the octal number system, the given number can be a decimal number and hexadecimal number. It cannot be a binary number because we defined one digit 2. 2 is not allowed in the binary number. In the third example, we defined a number and we are saying that it is an octal number. Like clearly it is not an octal number because in the formation of the number we used one digit, that is 8. 8 is not belong to the octal digits. And for the fourth example, we defined a decimal number. Clearly, it is not a decimal number because in the formation of the number, along with the 0 to 9 digits, we used one alphabet C. In decimal number system, the alphabets are not allowed. So, the fourth example is not a decimal number. And in the fifth example, we defined one binary number. Clearly, it is a binary number. Yes, it is a binary number because in the formation of the number, we used only 0 and 1 digits. Along with the binary number, there is a possibility of this example to be an decimal number, octal number, and hexadecimal number as well, because in all these three number systems, 0 and 1 is allowed. That's all for today. Thank you.